The way I think of Super Mario Brothers being is Mario jumps up and down and the background scrolls right and left, and then it makes a game. If you want to do it with just the view moving, that would work too. And in fact, here's the main message. Anything you want to do, you should be able to do. So if there's anything you wish you could do and you don't know how to do it, then that's fair topic for this class, and I'd like you to be able to pull it off. So if you want this background to scroll, you should. If you want Mario to run off the side of the screen and then it page flips to the next screen, we should be able to do that. Or let's just for uniformity's sake though, let's all have background scroll horizontally, Mario moves vertically. Sound good? Okay. Did I answer the question? All right, great. Well, shall we talk about how to do it? Okay. Build some code, run my code. Oops, I mean game. Here's what I've got. Looks like a map editor. I can place some tubes. I can wipe out tubes. There you go. We've got something. Okay, game. Oops. Game.java. Let's open it up. Now, it's probably time to take a look at our code a little bit and see how much we understand it. Everybody gets that it starts in main, right? And we all get that we've created a new game object and we've called game.run. And game.run has this loop, and loop just updates everything repeatedly. Okay? Is there anything that happens before main? There actually can be. Let me prove it to you. System.out.println. Hi, the program is beginning. Now, this is the first thing that will ever happen in the program, right? Is there any way to call code before this? Here's how you could. Suppose I come up here and I say static. What should I do? How about a string? Wait a minute. Static has to be lowercase. String s equals make string. Now I'm going to come down here and I'll add a static string make string function, which returns, what should my string say? Main? Super Mario Brothers. There. Okay. There, I made a string. And while I'm at it, system.out.println, wah, ha, 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 I am first. Okay. See if this works. My code builds. Java game. I usually name my main class main. That way I don't have to think about what it's named all the time. For some reason, I didn't do that in the starter kit. There you go. Okay, and here's my program running. And notice what it printed to the console. Wah ha ha, I am first, followed by hi, the program is beginning. And thus we have discovered that, in fact, main is not the first thing. Does that bother you? Bothers me. I mean, come on, main's supposed to be the very first thing ever. So why did make string get called before main? Last time we talked about static methods, right? I never actually talked about static member variables, did I? I don't think I did. So let's talk about that. For refresher's sake, what is a static method? Yeah, it's a copy of the method that intuitively is not part of the object. It's part of the class. So here's something you may not have known about Java. We have all this stuff on the stack, and these are all the local variables, and they are either primitive types or reference types. If they're reference types, they reference stuff that's on the heap. If they're primitive types, then the value is stored on the stack. And that squiggle represents the value, right? Okay. Well, it turns out that every object you may not have known this, has a corresponding class object. And I haven't been drawing this before. And there's a secret variable inside every class. It's not really secret. And that variable references the class object. Now, if I make a second instance of this type of object, let's say these are tube objects. You can have many, many tubes, right? You can have as many tube objects as you want, but there will always be one object for the class tube. And this is the class object. Does that make sense? So by virtue of the fact that you made a class at all, before the program even begins, Java allocates an object for every single class in your program. And whenever you use the word new, that's basically making another object that references that class and is the instance of the class. Now you know. Okay. When you say static in front of a member variable, it actually goes in the class, like right there. And when you don't say static in front of a member variable, as in these three cases, then it is stored here. And by here, I mean there's a copy of it, or there's a different one in every single instance of the class or in every single object. So it's very, very possible for any non-static or instance member variable to have three different values. Even though, what's the name of those member variables? It's, that wasn't a very well-worded question. What I mean is, all three of these member variables have the exact same name, right? So for example, if we called it model, which of these three is model? The answer is this one. All of them, right? Or yes is the answer. Whereas in my code here, S, that's this one up here. Now suppose you change the value of S. You see that it's the same S for everything, right? There's only one of them. Whereas if you change model, you can change one of those models, but the other ones won't change. Okay. Now that was a very confusing example because I said they were tubes and I was referencing the game class and I wasn't even consistent. And I'm sorry for my really bad, not consistent description. Do you get what I was saying, or do you need me to repeat it with consistency? Is anybody lost? Okay. Just repeat it again. Sure. Let's pretend these three objects are instances of type game, not instances of type tube. Okay? Whenever you call new, so I say new game, every single time I call new game, it's going to make a new game object on the heap. So one of these squares, this one, or this one, or this one, occurred when I said new game. Now my code only says it one time, so let's make it 3 times just so I'm consistent with my picture. We'll call it G, 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 and how about G, G, G? So I have 3 local variables, which are each referencing 3 game objects, kind of like this. And see how I have 3 objects? Because I called new 3 times. Okay. Now the one thing I didn't tell it to do is to make a class object. The reason I didn't have to tell it that is because Java does that automatically. So just because my code has a class game in it, as soon as my program begins, Java will allocate this object, and it's sitting there ready to use even before I created any of those game instances. When I say new game, it makes a new game instance, and every game instance will reference its class because it knows about the class. So if I were to say, for example, notice that my game class has a model in it. If I were to say g.model equals null, that will set the value of g, which we'll say is this one on the bottom, because I made it first. That'll set the value of this g.model to null. But it won't change the other two. I only changed one of them because that's an instance variable. Is there a question there? The class object is not referenced by any variable directly, at least not anyone you have access to. Well, you can, and here's how. Suppose then I say g.s equals banana, because I don't know what I want to change it to. If I say g.s is equal to banana, what's actually happening is it starts here with g, and it follows it to the object because g is a reference type. And then when I say s, it says, hey, there's no member variable named s here. And so the compiler knows, actually, you meant to go to the class object because there's an s right there. And it's going to change that one. And now, if I use one of these other things, like I say, system.out.println g.s, what will it print? It will print banana, because even though I'm using triple G here, that triple G, which is this one, is going to go to this object. There is no S here, so it's going to follow it up to the class object, and it'll use this static member variable one. So basically, the way you're supposed to think about it is the word static means not associated with the object. And what's an object? Well, this is an object, this is an object, this is an object. Objects are the things you allocate by saying new. Now, it's kind of associated with an object, but it's the class object. We don't really think of those as being objects because they're static. There's only one of them. They sit there in memory. They're taken care of automatically. So really, when I say object, I mean these. The ones you allocate that are instances that you said new for. And the thing with an object is there's not just one of them. That's really hard for students to get through their heads. You got to remember, you can make as many objects as you want, and every single one of them has all of the member variables in it. All of those. Unless you say static. If you say static, then it's not really in the object. It's really in this special class object that's global and is available to everyone. Does that all make sense? Okay. Now, because it's in the global object, I don't actually have to reference it with an object. I can actually just use the class name, and I can say game.s equals banana. Yes?
Is that bad practice to use that since it's so easy to access it outside of class?
It's generally considered bad practice to use statics at all. So, as a general rule, just never do that. And of course, all rules are meant to be broken. Okay? It wouldn't be there if there wasn't a valid reason to use it. So yes, you are supposed to use it sometimes, but pretty much, unless you have a good reason, don't use static variables. And for that matter, unless you have a good reason, don't even use member variables. One of the things that students do, I'll get to you in a second, that really bothers me is they start putting variables like I as member variables when I is used as an iterator a whole bunch of times, and they need another iterator, so they put a J in there, and they basically stuff all of the variables they ever need inside of their class. Why is that bad practice? Well, because if you allocate a lot of them, suddenly you have a lot of variables all over the place, and one, you're wasting memory. Now, of course, who cares? These days we have gigabytes of RAM. Doesn't even matter. But the other thing is, it makes your code more error prone, because let's suppose one of these variables has the wrong value, and now you have to ask yourself, who's the guilty culprit? Where are you going to have to look? Every single method in the class has access to it, therefore you have no idea. The bug is somewhere in this class. That's bad, right? Whereas, if you just allocate your local variables locally, like if I have a loop, I'm just going to stick it right in here and say, for int I equals 0, I is less than can I++, that kind of a thing. This variable I actually has scope from here to here. That's not a lot of code, and because it's not a lot of code, if I ever has the wrong value, I only have to look at that code. And that means my debugging life is easier. One of the big emphases of this class is how to find your bugs.